Welcome everyone to a session on big data analytics. In this particular session, we will be looking into one of the chapters of module 4, which is clustering. We have already looked into the concept of clustering in module 3 in data mining concept, right, in a data mining session, and we have already seen what kind of learning this is. This is a part of something called as unsupervised learning. So let us recall what exactly unsupervised learning is. Unsupervised learning is a type of machine learning in which the models are trained using unlabeled data sets and are allowed to act on the data without any supervision from the user. Okay, and along with this you have association analysis, which is also unsupervised. So this kind of unsupervised learning techniques does not give or yeah, of course it produces an optimal solution, but there is no way to judge whether the solution obtained is optimal or not. Okay, so unlike classification where we can measure the efficiency of the methods or model by using various parameters or various metrics like accuracy, precision, and when it comes to regression we can measure by using the evaluation metrics like R square, right? But unfortunately, when it comes to unsupervised learning, there is no way of judging or evaluating the solution with any metrics. Okay, so this is about unsupervised learning, and let us see what exactly clustering is.
Okay, now let us look into the definition of clustering or cluster analysis. So as per the definition, cluster analysis is used for automatic identification of the natural grouping of things. Okay, and sometimes it is also called as segmentation technique. So what do you mean by this? So here there are no labels as we have seen in classification where there are labels. We are classifying a record or a data point into various classes, but here we are not doing that, right? What we are doing is we are observing the various data points and we are grouping it together to form a cluster such that the members within the group are very similar to each other from the members that belongs to the other groups. Okay, and when it comes to clustering, since it is an unsupervised learning technique, there is no such a thing as right output, okay, right or wrong answers, and there are no labels as already said. Okay, so what we are basically doing is grouping. Okay, and the only parameter to evaluate is the group members should be very close to each other, and uh, it should be very far, or the distances between from one group to the other should be very large. So this is the only parameter to evaluate the cluster that is obtained, or the grouping that is done using the clustering technique. Okay, now let us look at the various application of cluster analysis. Cluster analysis is almost used in every field where there is a large variety of transactions. Okay, so especially when we have to group something, we can make use of cluster analysis where and the data points does not have any labels. Okay, in such kind of situation, we can make use of cluster analysis. So it helps us to provide characterization, definition, and labels for the populations, and it can help identify the natural grouping of customers, products, patients, and so on. And let us now see some of the major application fields. Okay, so in market segmentation, so this is about characterizing or categorizing the customers according to their similarities. For instance, by their common wants and needs, and propensity to pay can help with the target marketing. Next one is product portfolio. So this is about people of similar sizes can be grouped together to make a small, medium, and large sizes of clothing items. So this is about the just an example of product portfolio. And finally, the field of text mining, where clustering can help to organize a given collection of text documents according to their content similarities into clusters or related topics. Okay, anyways, we will be looking into text mining in detail in the upcoming module of module 5. So this is about the various application of cluster analysis. Now let us look into the definition of a cluster. Okay. So previously we have seen the definition of a clustering or cluster analysis. Now let us look into the definition of a cluster. So it is an operational definition of a cluster is that given a representation of n objects, okay, so the total number of objects is n, find k number of groups based on a measure of similarity such that the objects within the same group are alike, but the objects in different groups are not alike. Okay, so this is something what I've already explained. What we have is we have n number of objects. Let me take it as 15, okay, and k value as 3. So what I'm supposed to do is this 15 objects should be grouped into 3 groups. Okay, so I can have 3 groups where I have to distribute these 15 objects such that the members within the group are very similar and the members from the different groups are very unsimilar, okay, or very unlike, not alike. Okay, so this is about a definition of a cluster, or I can, or in a, see, with respect to this alike and not alike, I can define it as, what you will be doing is we will be forming clusters, right? So just an example, I'll be having 3 clusters. So there are many objects within the group. So in this case, see, the objects within the cluster are very alike. So what I can say is the intra-cluster distance within the cluster should be very small, and the inter-cluster distance, okay, so normally we calculate the distance from the centroid of these clusters, which should be this, if I consider this as centroid, okay, C1 and C2. So this distance should be very large and the intercluster distance should be very small. So this is one great parameter to determine whether I have obtained a very good cluster or not. Okay, but there is no right answer with respect to the number of clusters. For example, yeah, we'll look into the example very soon. But before that, how can I judge or how can I, what is the notion for similarity in a cluster? So it can be interpreted in many ways. Cluster can differ in terms of their shape, size and density, and clusters are patterns, and so there can be many kinds of patterns. Okay, so there are various ways to find the similarities or to evaluate the similarities between the clusters. Okay, and an ideal cluster can be defined as a set of points that is compact and isolated. So in reality, a cluster is a very subjective entity whose significance and interpretation requires a lot of domain knowledge. Okay, for example, if you take this particular data point, how many groups I can have? So do I have one is now I have one big single cluster, right? So this is one big group altogether, but this is not very appropriate. So yeah, so let me erase this. Okay, how many cluster do I have? Do I have 2 clusters of equal sizes? So yes, in one way, yes. So this forms one cluster and this again forms another cluster, isn't it? There are 2 clusters. And if you if you look it in another way, then I can have 3 clusters also. So this is one cluster, this forms another cluster, and this is a small cluster with only 2 data points. So what is the right answer? So unfortunately, we don't have a very solid answer for this. We don't know which is the right number of clusters. Okay, so that is again dependent on the application and also the requirement. So there is no proper answer, as I have already mentioned. When it comes to unsupervised learning, we don't have the right answer with respect to the solution. Okay, and there is no such thing as a right output or wrong output. Okay, it is very subjective. So this is about the definition of a cluster. Now let us look into the clustering techniques. The quality of a clustering depends on these three entities, that is the distance function used, algorithm, and the application on hand. Okay, so let us look into all these three entities: distance function, algorithms, and application. Okay, first let us look into the distance function. So the normally used, the most commonly used distance function is the Euclidean distance, where I make use of the square difference between 2 points, summation of the square between the vectors, okay, and then I have to find the square root of it. Okay, so it is the square root of the summation of the squared difference between the vectors of the various data points. So if I have x1, yeah, so these are the two data points, x1 comma y1 and x2 comma y2. So what I have to do is I have to find the square root of the squared difference between x1 and x2 and y1 and y2. So this will give me the Euclidean distance between the 2 points. Okay. Anyways, we will take some example. The other commonly used distance is Manhattan distance. Okay, so this is very simple. So where we find the absolute difference between the associated vector values. Okay, so x2 minus x1, it doesn't matter whether if I write x1 minus x2 because we will be calculating the absolute difference, and then it is added with the absolute difference between y2 and y1. So it is basically the summation of the absolute difference between the various vectors, okay, of the data points. Let us consider some example. Okay, so this is these are the two data points, 2 comma 5 and 1 comma 3. Now if I apply Euclidean distance between these 2 points, then this is what I get: the square root of the summation of the square difference between the values. Okay, so this is x1 and this is x2. So if I apply the formula, then 2 minus 1, okay, 2 minus 1, I have to square it, is added with 5 minus, yeah, 5 minus 3, I have to square it, then I have to perform the summation, and finally I have to find the square root of this. So what do I get? Yeah, so this is like 2 minus 1 square, so which is nothing but 1 square, plus 5 minus 3, which is 2 square. So what do I get? I get 1 plus 4, so square root of 5, which is nothing but 2.23. So this is the Euclidean distance. Okay, the other method is Manhattan distance. So this is very straightforward. I have to find the absolute difference between the x values. Okay, so it is 2 minus 1, so I'll get it as 1 plus 5 minus 3 between these 2 points, 5 minus 3, so which is nothing but 2. Then I have to find and I have to calculate the summation, which will end up with 3. Okay, so this is the most commonly used distance function, but we will be, let us make use of Euclidean distance as it is more uh, efficient than Manhattan distance. Apart from this, we have other distance also, other ways of calculating the distance, like Jaccard distance, okay, which is not commonly used. Okay. So anyways, we can apply any one of these two, but the most commonly used is Euclidean distance. And for the further problems what we will be encountering, let us make use of Euclidean distance to calculate the distance. Okay, so this is about the distance function. Then when it comes to algorithms, I have a top-down hierarchical method, top-down approach, and I also have bottom-up methods. Okay, and the most famous top-down hierarchical method is a k-mean method. Okay, and when it comes to bottom-up methods, I have algorithms like agglomerative method. Okay, so anyways, we will be looking into the k-means algorithms in detail with an example. And the other technique what we use is the artificial neural networks, which can be used for clustering. ANN is something, yeah, it is again another chapter in module 3, which we will be taking in the upcoming session. So I can make use of artificial neural network for clustering, or I can make use of the top-down and bottom-up approaches, clustering approaches to calculate the method. And the most famous and the most, or I can say the most or the best algorithm to find the clustering is k-means algorithm. Okay, which is a top-down method. And the example for bottom-up approach is agglomerative method. Okay, agglomerative method. Unfortunately, we don't have this in our syllabus. We will be looking only into the top-down approach, which is k-means approach. Okay. So this is about the clustering techniques. We have discussed about the distance function as well as the algorithms. Okay, now let me explain the general pseudocode for clustering. So what we do is the first step. So this is a general pseudocode. Okay, not very specific to a particular algorithm, but if you generalize the clustering algorithm, so these are the steps that need to be followed. First thing what I need to do is I have to pick an arbitrary number of groups. Okay, so this is the number of clusters, arbitrary number of groups that need to be created, so which has to be manually entered or manually determined based on the domain knowledge, and also with respect to the application in hand. Okay, and application in the sense the problem statement in hand. Okay, then I have to start with some initial random chosen center. We call it as a centroid. So again, this has to be selected manually, center value. Then I have to perform class. I have to do the clustering. Now we apply the clustering algorithm where I classify the instances to the closest group. Okay, so this initial number of cluster is determined. Suppose let me take it as 3. Then 3 centroids need to be created, center values. And then what I have to do is the various data points need to be assigned to the 3 groups based on the distance. Okay, so I have to apply the distance function, and then I have to assign the data points to the various clusters, that is various groups that is already determined by us. Okay, so this is based on the distance function. Okay, based on the distance function I have to assign the data points to the various centroids. Then after that I have to compute the new values for the group centers. Yeah, so after assigning this data points, I'll get a new centroid value, new centroid. Anyways, we will be looking in detail how this algorithm or how this pseudocode works. Okay, in general. Okay. Okay, then what I have to do is then I have to repeat this step 3 and step 4. Okay, so again, after getting a new centroid, again I have to calculate the distance between the various data points. Then I have to perform the updation. Okay, so these steps are repeated maybe for a fixed number of times, maybe so this is repeated maybe for some 10 iterations. Okay, just an example. This is one way, okay, where I have fixed number of iterations like 10 or 15. Okay, so these are repeated. Or what we can do is we can repeat this until there is no change with respect to the grouping with respect to the previous iteration. Okay, so if fourth iteration gives me some groups, and in the fifth iteration if I get the same group, same if there is no change with respect to the answer obtained from fourth iteration and the fifth iteration, then I have to stop. Okay, So I can repeat this until based on these two criteria. And finally, if the clusters are not satisfactory, so the final answer what we got is not satisfactory, we have to go to step one and pick a different number of groups and segments. Okay, so if I am not satisfied with the answer what I got, I have to go back to step one. Then I have to change this cluster value maybe to 2, or I can increase it to 4. Okay, and also I have to select a new centroid value, initial centroid value. So these steps are repeated until I am satisfied. Okay, until the answer what I got is satisfactory. So this is how this is the general pseudocode for clustering. Okay, now let us consider some clustering exercise. Here we have a data set. Okay, x and y. These are the individual data points. Okay, with the two vector values x and y. So this can be written as 2 comma 4, and this is 2 comma 6, and so on. Okay, so how many data points we have? 1 2 3 4 5 6 7 8 9 10. So the n value is 10. This is nothing but the number of objects. Okay, first let us look into the bottom up approach. Okay, here we are not going to discuss about any algorithm, so that is not there in the syllabus, but let us simply see how a bottom up approach would work with respect to creating the clusters. Okay, first, so these are the uh, yeah, so this is the x or x values, and here I have the y values. Okay, and together they form these data points. So there we had n objects, or 10 objects, isn't it? So we have 10 data points, as you can see. 1 2 3, yes. So this will add up to 10. And let me go back. So this 2 comma 4, so here it is 2 comma 4. So this is how we have pointed or represented the various data points in the graph. Okay, so 2 here with respect to x-axis, and 4 with respect to y-axis. So similarly the other data points. Okay, so this is the graphical representation of the various data points, and we have to find the groups, or we have to find the similar observation and find the clusters. Okay, so with the bottom up approach, we always start with the single cluster. So this entire 10 objects is considered initially as a one big single cluster. Okay, so this entire data points is considered as a part of a huge single cluster. Of course, this is of no use, right? But anyways, this is the initial value. So anyways, we have to, with the iterations, we have to improvise the cluster. And initially with this n object, I have a single cluster where k value is equal to 1. The total number of cluster is 1, and this is the centroid value. Okay, so this is the center of the cluster. So how did I obtain the centroid? It's very simple. It is the summation of the x value divided by n. So this will give me the x-axis value, and comma summation of y value divided by n. Okay, so let us see whether we got the right answer or not. So all the x value we have to add, that is 2 plus 4, so this will give me 6. 6 plus 5 will take me to 11. 11 plus 5, 16, plus 6, which is 22. Then I have 8 here, so 30, 36, 41, 40, 5, and 47, right? 47. So 47 is the total summation of x value, and n is 10, so that will give me the value 4.7, and this is the 4.7 what we got. Okay, with respect to x-axis. And similarly the summation of y, which will yeah, these values we have to add up: 6, 7, 7. So this will 14, 20, 26, 32, 35, 38, 40, 44, 48. So 4. So the summation is 48 divided by 10, which will take me to 4.8. So this is the centroid value with respect to x and y axis. This is a very simple calculation to find the center of the cluster, okay, which we call as centroid. Okay. Now, see, as you can see, this is not a proper cluster, and which is of no use, right? A single cluster. And as you can see, there is a huge distance between this point, this data point 2.6 and 8.3. So what we can do is we can improve or we can increase the k value. Okay, so this is what we do in a hierarchical agglomerative method, that is bottom up approach. So if I increase k value, then I will get two clusters, right? So the k value is 2, which means I'll be having two centroids. Okay, so this is yeah, this is a part of it. So this will form one cluster, and these 3 points will form another cluster. Okay, so here again you have to find the new centroid. So based on these values, okay, which will be 4, and with respect to y it is 5.7, and here I'll be having 6.3 and 2.6 based on these three data points. Okay, so this again looks better than the previous iteration value, where there is a these 2 points, so 2.6 and 8.3 are in two different groups, right? And the objects within the group are somewhat closely associated, or the distance between them is very small when compared to the previous iteration, whatever we had compared with this one. Okay, but still I can still improvise this with as you can see, there is a this cluster C1. If I name it as C1, this as C2. Still there is a huge difference between distance between this data point and 6.6, right? So I can still increase the k value, number of clusters, and this is something what I get. Okay, this will form one cluster, this will form another cluster, and this will form another cluster. Okay, now as you can see here, this has with the k value is equal to 3, and with the new centroids, okay, I got a better result when compared to k is equal to 2, and this has given a very good observation or grouping, isn't it? The objects within the clusters, or the data points within the clusters, are very close to each other, so that can be determined by calculating the sum of the or mean of the distance to the from these data points to the centroid. It is very small, and these intercluster distance is very large. This is very large, whereas intracluster distance is very small. Okay, so this particular cluster C1, let me, if I name it as C1, has provided or produced a very good grouping. Okay, but if you compare it with this one, here it is not so much. See, this particular group is very there's a lot of distance between the data points. Of course it is one, yeah, if I name it as C2 and C3, yeah, see, this is another cluster, but if you observe, the data points are still very far from each other, so this is not much of a usefulness, right? But having said that, there is no proper, as I have already mentioned, there is no proper output, or there is no right output or wrong output for the clustering approach. Okay, since it is a problem that doesn't have a label, and it's an unsupervised learning, we simply have to know the domain knowledge with the domain knowledge, and everything depends on the k value whatever we have seen. We can stop the iteration. So if I take k is equal to 4, I'll get 4 clusters, right? And if I increase k up to 10, then each of this data point will form its own cluster. So I'll be having 10 cluster, and each of these cluster will be the individual data point. So I cannot increase up to 10. So cluster value shouldn't be a very huge value, because if at max I can go up to 10. So where each and every data point forms a cluster of its own, which is of no useful at all, right? And the data value, k value, cannot be very less also. It cannot be equal to 1. So even this is of no much of a use, where I'll be having one single observation or one single group. So I should be very careful um, with the selection of k, right? With the selection of number of clusters. So everything depends on these values. Okay. So this is how a cluster would be formed if I make use of a bottom-up approach, where I start with a single cluster and increase the k value or the number of clusters, and get more number of groups. Okay, so here we will stop with the k value is equal to 3, because this has provided a pretty much good clustering result, right? Okay, so this is about bottom-up approach. Of course, I have not explained the algorithm, because in our syllabus we don't have an algorithm with respect to bottom-up approaches like agglomerative method. Okay, but anyways, we will be looking into a top-down approach, k-means algorithm, which is considered as the best clustering algorithm um, we have. Okay, so let us look the same example with respect to k-means. Okay, yes. Okay, finally we will look into a very popular clustering algorithm, that is k-means algorithm. Okay, so this is the most preferred algorithm to find the cluster. And let us see how exactly k-means algorithm works. K-means algorithm, it iteratively computes the clusters and their centroids. So it works in an iterative manner. Okay, so some steps are in the algorithms are repeated iteratively until certain conditions are, and it's a top-down approach. I have already mentioned this. It's a top-down approach to clustering. And see, we start the algorithm with the given k clusters. Suppose let me take it as three clusters. That means three random centroids will be created as a starting point to the centers. Okay, so this entire output of this k-means algorithm is dependent on the k value that is selected. Okay, so your output will vary depending on the k value whatever we select. This is left for the this is given as an input to the clustering algorithm, which is selected by the user. Okay, and the entire output is dependent on this, and also the three random centroids that is created. Okay, so everything is dependent on this, the random centroid that is created, as well as the k value. So if you get a different output for the same problem, then that means your output may not be wrong. Of course, there is no right or wrong with respect to clustering, but the for the same k value, I may get different result. That might be because of the initial random centroid that is selected. Now let us look into the problem. Or first, before that, let us look into the working of the k-means algorithm. So k-means algorithms take this as input, that is a k value, whatever I have mentioned. Let me take it as 3, and the data list. Okay, so these are the data points. Let us take the same data points what we have considered previously, where n is equal to 10. Okay, so that data points, all those data points list will be given as an input to the k-means algorithm. Of course, this is a pseudocode. Uh, Detailed explanation is not given in the pseudocode. Then we have, yeah, choose k number of random data points as the initial centroid. Okay. So randomly we will select k number of initial centroid values. Initial centroid values. Anyways, you will get a clear understanding once I explain the uh, algorithm with an example. So initially some random centroid will be created based on the k value. Then you have to repeat the following steps until certain condition is true. Okay, so these are the two steps that we have to repeat. First one is allot each point in the data to the nearest k centroid. Okay, so what we have to do is, so this is given, right? This data point is given and the three centroid value is also given. So what I have to do is, I have to calculate the distance from each of these data points to all the three or all the k centroids. Okay. Then based on the smallest distance, I have to allocate that data point to the cluster. So this is about allocation. Allocation is done based on the distance. Okay, based on a distance, and the one that has minimum distance among the k centroids, then we have to allocate that data point to that particular centroid that gives me the minimum distance, or that has the smallest distance. Of course, the distance need to be calculated by using the Euclidean algorithm. We will prefer Euclidean algorithm over Manhattan. Then after this, yes, after allocation, we have to compute the new centroid for the clustering that is obtained using all the points in the cluster. Okay, so we will get the new groups, right? After allocation, we'll get a new groups, and from that we'll get a new centroid. Okay, and after this, what we have to do is we have to again go back to this step. Okay, so from the new centroid, again I have to calculate the distance to each and every data point, because with the new centroid again the distance might change. There is a possibility that the distances will change, and again um, I have to repeat this step, right? So again I have to do the allocation based on the minimum distance. So this step will be repeated until certain number of iterations, maybe a fixed number of iterations, say 10. Okay, so this is one way to stop the iterations. Or you have to repeat this iteration until there is no change with the cluster allocation when compared to the previous iteration. Suppose the fourth iteration has given me one cluster value. Okay, and the fifth iteration, when I perform the fifth iteration, then there is no change with respect to the result obtained with respect to fifth and fourth. Then I have to stop, which means there there will not be a further change in the clustering or grouping. Okay, clustering or grouping. So in that case I have to stop. So this is how the k-means algorithm, this is the pseudocode for the k-means algorithm. We'll get a clear idea once we look into the problem. Okay, now let us see the clustering result for the same data set what we have considered for this particular data set. Okay, so these are the data set where I have 10 objects, and let us apply the k-means algorithm for this and see what result we get. Yeah, um, yeah. So this is the initial iteration. Okay, initial iteration. So here in this clustering algorithm, as I said, we have to select the k value, and we have taken k value as equal to 3, which means I will be having three groups or three clusters. Okay, and with this k value, initial k value, as I've already mentioned in the pseudocode, see, this is the choose the k value. So this is what we have chosen, 3. It is taken as 3. So randomly three data points as the initial centroids will be created, right? So this is randomly selected. So these are the three data points that is selected. As you can see, the one is C1 with the point 1 comma 6, that is x value is equal to 1 and y-axis 6. Okay, so this is one centroid, and this is randomly selected. C2, which is having 8 comma 4, and finally C3 with 4 comma 1. So these are randomly selected data value, and of course the entire result of your clustering is dependent on the k value and the initial random centroid that is selected. Okay, so if you take a different initial random centroid value, you will get a different result even though for the same k value. Okay, Yeah, so this is how k-means algorithm will work. So this is the initial value, and now what we have to do is we have to, let me go to the pseudocode. See, this is the steps what I have to repeat. Allocate each point in D to the nearest of the k centroids. Okay. So what does that mean? So each of these points, right? See, so these are the data points in the list D. So I have to allocate each of these values or data points to the cluster. So how that is done? That is done by calculating the distance. Okay, so yeah, I'll keep a small table here. Okay, so I'll be having um, data points, and I'll be having the three clusters here. Okay, so this is the distance what I have to calculate, C3. Okay, yeah. For example, I'll not be calculating each and every point here. It's just uh, that you have to do as an exercise. Okay, but I'll be explaining how exactly the data point distance will be calculated. So if you take 4.7, for example, this particular point 4 comma 7. Okay, x value is 4 and y is 7. Okay, so with this 4 and 4 comma 7, I have to calculate the distance to each of these centroid values. Okay, so with respect to C1, so let us see distance between 4 comma 7 to C1, which is 1 comma 6. Okay, so what is the value? This is C1, right? Okay, how do we have to calculate? Let me apply the Euclidean algorithm, which we have already seen. The working of Euclidean algorithm, that is x1 minus x2 the whole square, that is 4 minus 1, these values, right? Square difference plus 7 minus 6 the whole square. So how much I will get? 4 minus 3, 4 minus 1 is 3 square, which is 9, plus 7 minus 6, which is 1. So I'll get square root of 10, right? And what is the square root of 10? Let us calculate. Square root of 10 is equal to 3.16. So this is the distance what I got, 3.16. Okay, so this is the distance between this point, this 4.4 comma 7 with respect to C1. Okay, so let that distance I'll write here as 3.16. Okay, then similarly with respect to C2 I have to calculate. Okay, so C2 is here, right? Okay, yeah, let me erase these points. Okay, that is a distance from 4 comma 7 to C2, which happens to be 8 comma 4 C2. Again the Euclidean distance formula we have to apply. So 8 minus 4 whole square plus 7 minus 4 whole square. It can be 4 minus 7 also, because see, when you square the difference you will get a positive value, right? 4 minus 7 um, will end up as minus 3. Minus 3 whole square is equal to 9, and 3 whole square is also equal to 9, so it doesn't matter, right? Okay, okay, so this will be 4 square, 16, plus 7 minus 4 is 9, so I'll get 25, which is equal to 5. So this is the distance what I got, 5. Okay, and finally coming to C3, I'll erase this. distance from the point 4 to 7 to C3, which happens to be 4 comma 1. C3, yeah. So this will give me the distance as 4 minus 4 the whole square plus 7 minus 1 the whole square. So this will give me 0 square plus 6 square, isn't it? 6 square in the sense 36. So this will be equal to 6. So the distance between the data point 4 comma 7 to C3 is 6. So among this, see, if you observe, the smallest distance from this data point to the three clusters is C1, isn't it? Because it has given me the, or it is having the shortest distance. So 3.16 is the smallest among the values. So what I have to do is I have to allocate 4.4 comma 7 this data point to the centroid or to the cluster 1 comma 6. So this will be coming here. Okay, this will be allocated to here. Similarly, this is just an example how you have to calculate the distance, which is nothing but the Euclidean distance. You have to Euclidean distance is what we have made use of to calculate the distance. So similarly, each and every data from each and every data point, you have to calculate the distance to the three centroids. Okay, and based on the minimum value, you have to perform allocation to that particular centroid. Okay, so this is how you're supposed to do with each and every data point. So with all the 10 values, I have to perform this calculation. Okay, so allocation of this data point 4 comma 7 will go to C1. Okay, so it will be allocated to C1. Yeah, so this, yeah, so the already the distance is calculated and just showing the representing the result. Okay, so this 4 comma 7 as we have calculated is allocated to C1, and 2 comma 6 is also allocated to C1 as it is very close, and 2 comma 4 also is allocated to C1. Okay, similarly 4 comma 4 is allocated to C3 and 5 comma 2 is allocated to C3. And these data points 5 comma 7, 5 comma 6, 6 comma 6, 6 comma 3 and 8 comma 3 is allocated to cluster C2. Okay, so after this, so once the allocation is done, so we are done with this step, isn't it? We are done with this step. Now we have to calculate what is the next. Yeah, this step has to be repeated. That is, compute the centroid for the cluster using all the points in the cluster. Okay, so what I have to do is using this. See, these three data points belong to C1, isn't it? Now using these three data points, I will get a new cluster. So that is, I have to find the new cluster for this three uh, for this particular centroid or this particular cluster, which is, how will I get 2? Okay, with the vector v x we will calculate first. 2 plus 4 plus 2. Okay, 4, 2 and 2. So what to, and it is divided by the number of data points in that cluster, which is 3. So how much I'll get? This is 8 by 3. So if you calculate 8 by 3, I should be able to get the value as 2 comma or 2.6, 2.66, right? So 2.66. So this will be the new centroid x value. Okay, similarly for the y1, okay, 7 plus 6 plus 4, which will give me 17. 17 divided by 3 will give me the value as 5.6. Okay, 5.6. So 2 comma 6 comma 5 comma 6 will be the new centroid value. Similarly, I have to calculate the new centroid value for C2 as well as C3. So if I calculate, this will be the new centroid I'll get. Okay, so this is as we have calculated just now. This is the new centroid for this particular cluster. Okay, so it has shifted, the centroid is shifted from 8,4 to 6,5, and here it has shifted from 4,1 to 4.5,3. So this will be the new centroid what I get. Okay. Then coming to the pseudocode, yeah, so we are done with this step as well as the other step, but we are not done with the final solution. What we have to do, so we have to repeat this until the cluster center stabilizes, right? Okay, so we have to repeat this. Yeah, so we have to repeat this again. So from this new centroid, whatever we have obtained from this new centroid, I have to calculate distance of each and every data point to all the three new centroids and check if there is a change with respect to allocation. Okay, and of course there will be some change with respect to allocation. Okay, as you can see previously this 6.3, this value or this data point was allocated to C2, but with the new centroid value, after calculating the new centroid value, it will be allocated to uh, C3. It will be allocated to C3. So why it will be allocated to C3? Let us check. Okay. So if you calculate the distance 6.6 comma 3, 6 comma 3 Euclidean distance, if I calculate 6 minus 4.5 whole square plus 3 minus 3 whole square. So this will give me 1.5 whole square, which is equal to 1.5. So this is the distance from 6 comma 3 to C3, and uh, the distance from 6 comma 3 C3 distance. Okay, from let us calculate the distance to C2. So C2, it will be 6 minus 6 the whole square plus 5 minus 3 the whole square. So what do I get? I get 2 square, which is equal to 2, right? Okay, so now as you can see, since there is a shift in the centroid value based on the new group, the distance from this data point to its original allocation has increased when compared to the new centroid of C3, isn't it? So what I have to do? See, 1.5 is less than 2. So what I have to do is I have to allocate this point to C3. So this is the new group I got, right? Previously that was allocated to C2, and now I get a new allocation. But there is no change with respect to this. And yeah, after doing this, after I get a new uh, allocation, again I have to recalculate the centroid. So if I recalculate the centroid, I'll get 5,3, and here since this has been deallocated from the previous C2, I should be able to get a new centroid again. There will be a change here value, so that will be 6 comma 5.5. Okay, so these are the new centroid value what I got. Okay, so this again repeat the steps. So in the third iteration, so this is second iteration. In the third iteration, there is no change with respect to the uh, allocation. Okay, so if there is no change with respect to the grouping, if I compare it with the previous iteration, then I have to stop the clustering, or I have to stop the iterations, and this will yield me the final result. Okay, so the final result of my clustering is obtained in this way. So this is one cluster C1, this is another cluster C2, and this is again another cluster C3. Okay, so this is the final result of my k-means algorithm. I have to stop when there is no change with respect to the grouping when compared to the previous iteration. So previous iteration also, yeah, so this is the previous iteration value, and if I recompute the distance and allocation, I did not get any change with respect to the allocation, so I have to stop. Okay, and so this is how the k-means algorithm work. And if you're not happy with the answer what we got, we can go back to step one. We can change the k value. Okay, change k, or we can try with the new random centroid points. Okay, if you had taken any other random centroid points initially, you would have got a different result. Okay, so everything is dependent on the k value and the random centroid points what we select. So this is about k-means clustering. Okay, selecting the number of clusters. So this is about selecting the k value. Since output is everything, output of a k-means algorithm is entirely dependent on the k value. Having the right k value is very important, right? But the correct value of the k is often ambiguous. It is very difficult to initially know what will be the ideal number of clusters. So initial k value, selecting the k value is very ambiguous task. Okay, and heuristics are required to pick the right number of k. So we require some heuristics to pick the right number of k for the given problem statement. And we can make use of this elbow method for determining the number of clusters in a data set. So what is this elbow method? So what we have is, we have on the y-axis we have the average within cluster of the sum of the squares, that is inter cluster distance value. We have in the y-axis with the within cluster, in the sense intra cluster. Okay, so we have the intra cluster squared sum of the distances, then average of the, sorry, it is the average of the squared sum of the distances from within cluster data points to the centroid. And here on the x-axis I have the number of clusters. Okay, as you can see, initially if the number of cluster is 1, I'll be having a high uh, average value. Average in the sense the intra-cluster distance will be very high, right, which is not ideal. But if I slowly increase the k value to 2, there is a drastic drop with respect to the intra-cluster distance. And if I change it to 3, still there is a drop. Okay, there is a sharp uh, drop, right? So this is in the shape of an elbow. This is in the shape of an elbow. And if you increase the k value further, there will not be much drop with respect to this point, right? So if you further change it to 5 or 6, there will not be a sharp change with respect to this particular point. Okay, so this will be considered as the elbow point. And normally this point, which gives me that sharp decline in the intra-cluster distance, should be selected as the k value. Okay, so how it is done? It is done by representing a graph where I calculate the average sum of the squared intra-cluster distance from each and every data points to the centroid. And on the x-axis I have to select the number of clusters. Okay, so as I increase the number of clusters, this has to come down. But after a certain point, a certain k value, there will not be a sharp change or decline in the intra-cluster distance. So this point has to be selected. This is an elbow point. Okay, so this point should be selected as the k value. So this is how we normally select the k value for the cluster. But of course, I have to experiment with all the different k values, and then I have to select the right uh, k value. So this is a very, a time consuming task, right? A resource oriented task, because if the data points are very high in terms of thousands, or maybe more, tens of thousands, then this will be a very time consuming tasks, right? Okay. Coming to the advantages and disadvantages of K-means algorithm. So first, let us look into the advantages. K-means algorithm is a very simple algorithm, and it is very easy to understand and easy to implement. It is also very efficient in that the time taken to cluster K-means rises linearly with the number of data points, and no other algorithm performs better than k-means. Even though there is no right output for the clustering algorithm, the k-means algorithm produces the best result when compared with other algorithm. But there are few disadvantages also. One is user need to specify the initial value of k. Okay, and everything is dependent on this k value as well as with the initial random centroid value. The process of finding the cluster may not converge, that is the second point, and it is not suitable for discovering cluster shape that are not hyperellipsoids or hyperspheres. Okay, so if you have a cluster of that different shapes other than hyperellipsoids, so whatever the shapes we have seen was hyperellipsoids, this cluster k-means cluster will have some problem in discovering such kind of cluster shapes. And we can apply the neural networks that can be deployed for clustering and using the appropriate objective function, and the neural networks will produce the appropriate cluster centroids and the cluster population of each cluster. So that is the other algorithm what we can apply for cluster or other machine learning model which we can apply for clustering apart from k-means. So this is about the k-means algorithms and the concept of clustering. I'll see you all in the next one. Thank you.